Imagining a universe with a cosmic designer machine. Can you imagine a different universe? Although the creation of our universe is something we all wonder about, this is an unusual question. Multiverse theories predict other universes. In this graphic, each bubble is a different universe. But what would they be like? There are many references to other universes. Brian Greene, in his YouTube Is Our Universe the Only Universe, says that a multiverse would contain many universes with fundamentally different features. But references contain few specifics, no visualization of different features. Most comments are general statements. For example, Max Tegmark, in his book The Mathematical Universe, says some would have no light or no gravity. This is a vague description. We would like to be more specific when describing one of the bubbles. To accomplish this, we need a framework for defining a universe. Because we want to stimulate our imagination without the technical details of theoretical physics, our framework will be conceptual and not mathematical. It will allow anyone to define specifications for a universe. The device we will employ is a cosmic designer machine. It has dials which define universe specifications. After explaining the dials, we will set the dials to create a virtual universe. Then, after describing our imagined universe, we will reflect on the complexity of our universe. 10 years ago, Paul Davies introduced the concept of a cosmic designer machine in his book, The Goldilocks Enigma: Why is the Universe Just Right for Life? With this machine, a designer, shown as a scientist, could change the mass of fundamental particles and the strength of forces by rotating dials. This is traditional fine-tuning. He concluded that even small adjustments would change the structure of the universe and prevent life. The Big Bang description of how our universe evolved is predicated on specific values for masses and force strengths. Our plan to imagine a universe will take a more global approach by considering all possible dials. This requires an enhanced cosmic designer machine. Our enhanced version of the original cosmic designer machine is the conceptual device shown. The number of dials have been expanded to create a more powerful machine. The big dials define the laws of nature. It may not be obvious, but the laws of nature are more than the laws of physics. They include universal rules and symmetry. We will further define the three terms in a moment. The small dials represent traditional fine-tuning, as previously shown on the original cosmic designer machine. The last set of dials control initial conditions and define how the universe began. For our universe, this equates to the start of the Big Bang. Initial condition dials include such things as space boundaries, energy, number of particles, movement of particles, and fundamental constants. After the dials are set, the machine generates a virtual universe. Now we will take a closer look at the laws of nature. The 5 universal rules are the first big dials. How are these dials set for our universe, and how might they change for an imagined universe? Starting with mathematics, what is the alternative? Well, without mathematical order, chaos would rule. Thus, laws based on math is a basic requirement. For our universe, the number of effective dimensions of space must equal 3. A universe with 2 space dimensions is a flatland with no depth to anything. With 4 dimensions, there are no stable orbits. Addressing time, if there were more than one time dimension, nothing is predictable. Thus, our imagined universe will need 3 space and 1 time dimension. For our universe, the force dials establish the 4 forces: gravity, electromagnetic, strong, and weak force. As our example will illustrate, eliminating or adding forces is one obvious way to modify a universe. In addition to the familiar fields associated with forces and particles, other unique fields exist in nature. The Higgs field, permeating all of space, is responsible for particle mass. Then there's the dark energy field. It contains most of the energy in our observable universe, yet it is a complete mystery. For our universe, these fields are required, but they are not required for an imagined universe. The four fundamental particles making up stable matter are the electron, the neutrino, up quark, and down quark. These particles have distinguishing features such as mass, charge, color, flavor, and spin. For example, the strong force only acts on quarks, which possess the color feature. Thus, a direct relationship exists between forces and particles, which are defined by the particle and force dials. Particles could obviously be different in an imagined universe. Now turning to the laws of physics. These 5 laws of physics control the everyday world via chemistry and physics. It's interesting to consider how intuitive they are. For example, in thermodynamics, conservation of energy and heat flowing from hot to cold seems reasonable. For electromagnetism, waves having both electric and magnetic properties less intuitive. For special relativity, a maximum speed limit and energy equivalent to mass even less intuitive. In general relativity, combining space and time is a real surprise. But the least intuitive of all is quantum mechanics, with concepts such as uncertainty principle and entanglement. As physicists frequently comment, no one understands quantum mechanics. An imagined universe could have all of these laws, some of these laws, or completely different laws. Next, we will discuss symmetry. The last big dial is symmetry. In our universe, the 2 required symmetries are Lorentz and gauge. Lorentz symmetry ensures that laws are the same independent of location or motion. Gauge symmetry applies to particle physics. It is more abstract and results in conservation of charge, spin, and color. Now, perfect symmetry would dictate absolutely no change in anything. Thus, nature features spontaneous symmetry breaking. It is believed to have created an imbalance between matter and antimatter. These or other symmetries might exist in an imagined universe. This brief overview concludes our discussion of the big dials. As for the small dials, we stated earlier that they establish the masses of elementary particles and the strength of forces. Next, using our cosmic designer machine, we will imagine a different universe with different dial settings for the large, small, and initial condition dials. So let's propose an alternative universe by setting dials. The first dial, mathematics, is set on. There will be mathematical energy and momentum laws. For dimensions, the observed 3 space and 1 time dimensions. There will be 1 elementary particle. It is a sphere 2 centimeters in diameter. In fixed positions opposite each other are positive and negative charges. There are 2 force fields. Force 1 attracts opposite charges and repels like charges. It extends out from the particle's surface a very short range. We will define a second force in a moment when we discuss the process. The laws of particle physics are straightforward. Indirect collisions of particles are similar to billiard ball collisions, except momentum is conserved. There's no loss of kinetic energy. However, if a positive charge of one particle collides directly with the negative charge of another particle, the particles permanently combine. When they combine, their kinetic energy is converted to binding or cohesive energy. Additional combinations form a chain like beads on a string. Lorentz symmetry for time and space is selected, so laws are independent of location or relative motion. Particle mass is arbitrarily set at 1 gram. The first force is significantly strong to bind particles at conservative velocities. Force 2 is variable depending on particle or string momentum, as we will describe. Next, we must establish initial conditions. Space is defined as a fixed sphere with a radius of 100 meters. There are 1 million particles moving in random directions at 10 meters per second. The source of energy is miraculously created by the cosmic designer machine. When the enter key is pressed, time starts with the existence of particles, forces, and motion. Over time, direct particle collisions form long, straight chains of particles. Total motion is reduced as kinetic energy is converted to cohesive energy. Our second force field exists on the interior of space and forms a hollow spherical shell which repels particles in chains with momentum equivalent to the incoming momentum, just like a rubber sheet. As each chain grows, the merging of particles becomes less and less frequent since there are fewer free particles. Equilibrium is eventually reached when particle change extends to the inside surface of the sphere. Within the 100-meter radius of the sphere, most of the million particles would eventually form about 100 chains, each with slightly less than 10,000 particles. Almost all the particles would be in chains like pickup sticks suspended in a sphere. A few particles would never combine based on the geometry, which prevents direct collisions when chains are close to maximum length. I'm not sure how long it would take to reach an equilibrium state, since we are thinking logically without the benefit of a cosmic designer machine. What the universe has: space, time, a particle, two forces, a few basic laws, Lorentz symmetry, a source of energy, and a process. What the universe does not have: light, gravity, atoms, stars, and DNA. Remember Tegmark's speculation of a universe with no gravity and no light? Now we have one. Other than a general concept, there are few similarities between the imaginary universe and our universe. Now that we have created a simple virtual universe, let's contemplate the dial settings for our universe. Think of the complexities and interactions required to produce clever results, such as atoms, stars, and DNA. As Richard Feynman said, all things are made of atoms, little particles that move around in perpetual motion. The atom requires quantum mechanical features, such as an electron having a nonspecific location described as a probability wave. Also, electrons reside in discrete energy states or orbits. If an electron moves from one orbit to another, it generates or absorbs a photon of specific energy. These features would be difficult to invent. Physicists are still astounded by quantum mechanics. Of course, to exploit the nuclear energy in atoms, they must be compressed. Gravity is nature's answer. Although a force roughly a trillion times weaker than other forces, it is relentless and nothing can hide from it. Gravity forms stars, which convert nuclear energy to light and other forms of energy. Think about how precise dial settings must be to form stars lasting billions or trillions of years. Then somehow, from these stars and atoms, there evolves organic life based on the mystery of DNA. These are very clever results from unique dial settings. So in conclusion, what have we learned from the Cosmic Designer Machine and the options it provides? We started by asking, can you imagine a different universe? Then we defined features required for a universe as dials on a Cosmic Designer Machine. Since each dial has multiple settings, there are a very large number of options. The machine was used to imagine a rather simplistic universe with one particle and two forces. It might represent one of the bubbles in a multiverse scenario. It had no light or no gravity. Others may attempt to imagine a different universe by setting dials and then conceptually predicting the outcome. This is thinking on the grandest scale possible. The task is interesting and challenging. I encourage you to try. However, it can be frustrating. The frustration results because it is difficult to predict interactions with more than one particle and more than two forces. If only we had a real Cosmic Designer machine to play with. However, any attempt to imagine a different universe assures a greater appreciation of our universe. Hopefully, by presenting a framework for imagining a virtual universe, I've provided a guide for your imagination. Thank you.